As we mentioned before, there's a nice way for us to measure a linear association between two variables. This is called the correlation coefficient, and we're specifically talking about Pearson's correlation coefficient, which is represented using an R. As a reminder, the correlation coefficient only measures a linear association, so it won't take up things that have patterns like parabolas or exponentials, which means that before we go ahead and calculate our correlation coefficient, we should probably make sure our data looks vaguely linear, or that that's what we're actually trying to test for. Now, in general, the correlation coefficient runs between -1 and +1. And as it runs between -1 and +1, that tells us some interesting stuff about our data. A negative correlation coefficient means that we have a negative association. Positive correlation coefficient means there's a positive association. On either extremes, we have a direct linear association. So, for instance, r equals -1 means our data is in a straight line that's angled down. It doesn't tell us how strongly it's angled down, like is it directly down, is it kind of at a 45-degree angle, is it more flat? All it tells us is that it's exactly a line and angled down. On the opposite side, an r value of +1 means I'm in a straight line headed up somehow. Values in between mean that I'm not in a straight line. An r value of 0 means that there's no linear association, which means my data is probably scattered about. The closer I am to 1, the more linear my data is. So an r value of 0.7 means I'm angled up and pretty close to a straight line, while an r value of 0.2 means I'm angled up, but it's a pretty loose association with the variables. Now, in review, we need to keep in mind that Pearson's correlation coefficient runs between -1 and +1. Paying attention only to the positive side of that, then, we can go ahead and start by looking at the plot in the upper left. This has a correlation coefficient of right around r equals 0, as there's no apparent pattern going on there that's trending upward or downward. The next one we have here might have an r value of 0.2. That is, there's a definite upward trend, but it's not very closely knit into something that's linear, as it's not forming a very good line. As we move over, this might have an r value of 0.7. It's, once again, angled up. We don't care how steeply, we just care the fact that it's more of a line shape. And finally, down here, r equals 1. Forms a perfect line angled upward.